of things already covered in the conversation, but it's also for other people. So for this presentation, I will focus on what is DynamoDB and what is pros and cons. Probably that's the thing you guys should know. And also when to use it is also a very important thing. Even though for the people who have interest in the data science, you better know this kind of option you have for database, right? So this is
he's just scaring you. Ooh.
Didn't say that. So DynamoDB actually is a AMD version of distributed database, NoSQL database. So what is DynamoDB? Is actually just a key value and document database. It's pretty much like a Cassandra or MongoDB. It's a little bit different, but pretty much the same. But it's just a Amazon version and hosted by Amazon, so it's a serverless service you can use. The NoSQL is serverless, and here is a I won't say typical, but it is a table for DynamoDB. So it's not like a, it's pretty much like you can see this. It's some row missing some attribute, but it seems like a traditional relational database, right? You have this table, you have row, you have attributes. So this is the value in each attribute. You can see this row, this pretty much like a user table, I would say. You don't have email, you don't have to put it here. So it's pretty flexible in terms of the schema. This is what DynamoDB is. And pros and cons. So let's talk about good thing first. So what good thing is the biggest thing is performance and skill. So I'm not saying the relational database has a fine performance. Actually, they're old technology, but it's very, very reliable. It's really fast in some cases, but when you reach the point, you have to scale. So what the relational database can do is scale up instead of horizontally scale out. So which means if you got this instance and you got performance issue, all you can do is you change it to the bigger instance, the more powerful machine. And if you got other performance issue, you change it to a bigger one. So eventually you will hit the limitation. How the the one machine, how many CPU you have, how many hard disk space you can have, and memory. There's a limitation. Of course, it can be very large, but it still have a limitation. But nowadays, a lot of especially I saw a lot of case, the startup companies, especially dealing with some social media, some kind of software. They really have a lot of data, so they can be very, very fast. So when you hit the limitation, actually the relational data can do very little about it now. But on the other hand, the NoSQL data, this is not just related to the data. This is the truth for all NoSQL database. So they can scale horizontally. Right? You use a lot of small nodes or you say servers, and to scale horizontally. Like you have one node, you have a problem, you can add another one. You have a problem, you can add another one. So technically there's no limitation for scale like that. Because you can add as much as you want, right? Especially for the DynamoDB, it's hosted by Amazon. As long as Amazon wants to sell you the server, you can use it. There's no really problem. This statement, I got it from the official website. This is one of their clients. This is how they use DynamoDB. So they can handle more than 10 trillion information per day, and the peak requirement is 20 million per second. That's insane.
Is that per instance?
No.
I thought
no, that's a whole system. You should treat this
too powerful.
system.
Too powerful.
So you cannot say one instance. This one instance.
Okay.
It's a really bad performance compared to the relational data service. So the key is to use very poor hardware to support this. I know it's very cheap hardware, so I don't care about if you fail. I can just replace one. I don't care about if you performance issue. I just add one because it's cheap. So that's a key. And also, you have a security support now is support encryption address by default. So the data is pretty safe. I will say availability they will cross the availability zone automatically, even though you can cross the region automatically. So because one region is like US East, US West, and Central. If this region has some problem like earthquake, it lost the region, but your data is still there, so it's still running because you will cross the region for the replication. So the user can just read your data from other regions.
So the data is distributed.
Distribute from two. One is this is called distribute. This is in one region or one of the regions. The data here in the relational database, you put, let's say you have 5 tables, you put your 5 tables all in one server. But here, you have 5 tables. One table, let's say we have users. I can put 10 users in this node, other 10 users here, other 10 users here. Why we have to distribute it? If you have other, front-end server want to require this user, in this case, relational database, you have to require all of the users from one server. So all of read and write will go to one server. This system, NoSQL system, distributed database. You can read 10 users from here, 10 users from here, 10 users from here. So also distribute your workload. So every node gets evenly, ideally, you can get evenly distributed workload. So, which means I don't want to keep this one user, one server like this server on 2 parts. So you can distribute your workload to the different users. And when I talk about the cross region, this is in one region. They will copy it in another region. Say exactly the same, and you pattern automatically. You don't have to pay more for your data safety. That's pretty cool. If you want to do that by yourself, good luck with that. You have to buy other, host of server and you do exactly the same thing and transfer data by yourself. That's a lot of money to have to spend. And for the backup, for the relational database backup, because they just have one server, the backup you also have to read your data from. You will add the workload to your server. This is overhead to your server. But for the not for NoSQL, but this is just for DynamoDB. DynamoDB have a feature called streaming. So basically, just when you write something, they can simultaneously pull this data to a streaming server, and then they use this streaming to do the backup. So what you can get from that, no performance impact to the server. You can just back up, and your performance will not go down. You will not hit your server hard. And also, also the backup, they support this called point in time, because they keep you insert one row here, they just keep it like a log. So they keep everything you change in a log. So you have ability to say, I want to go back, let my database go back to yesterday 10 p.m. You can do that. You want to go back to 10:30, you can do that. You can point a time, just to go back to that time. Yeah, that's pretty powerful. It's really powerful. And also the DynamoDB have other features like this accelerator called the DEX. Pretty much just like their manager Reddish in front of DynamoDB. You use this as
the what now? The man.
This one is just like a Reddish in front of.
Oh, Reddish.
Yeah.
Cache.
How do they do the point in time?
Every time you write something or change something, they keep a log. They insert one log.
So they've also got the time tab.
Yeah, for sure. They have timestamp. They have timestamp and log what you did. So when you say I want back to exactly what time, they can find that log and just get rid of that. Another feature is very important called TTL. It's called time to lead. This is just you can use one more here. You can use one more attribute like a timestamp to say, I want to my data just live in this table for let's say 1 year, and after 1 year, because you know a lot of after 1 year or after certain time, people will really barely require that data. So there's no reason I keep it in this table, just to increase the cost. So if you have this, you can combine this with some other service like Lambda to say, oh, if this time, this time, I just call my Lambda function and shape this to the backup, so like the S3 or something, remove it from the table. So that's it, what you can do.
Okay, so what you are presenting here in the pros is that the advantage of DynamoDB compared to traditional.
It's actually not just a DynamoDB, it's all SQL database compared to the traditional relational database.
So the traditional one, they don't have the functions.
We do, but not by default. That's why you get data break, they can get credit card number. This one, even though they go to your database, even though this is not our problem, I'm not going to handle that, right? Even though they did, you still get an encrypted data. And no performance hit. But the relational database, if you want to do that by yourself, definitely you have to encrypt. Traditional one, the backup, the big thing here actually is no performance impact. In the relational database, definitely have the impact because you have to read from your server again. Yeah, you code extra. That's why if you created a relational database, whatever database on RDS, they will ask you what period of time you want to do your backup. Usually you will choose like in the middle of the night, whatever, you have to choose that time. Another question. So that is a good thing. So the bad thing for the NoSQL database, not just for DynamoDB. The biggest thing I was talking about last time is the query flexibility. When people talk about the NoSQL database, first thing, a lot of you, including myself, not too long time ago, I'm still thinking about the NoSQL data is pretty flexible because we don't have to need all column in the same table, right? It's completely wrong. If you want to that performance, you have it in this distributed database. The NoSQL database is really not that flexible. You have to know your access pattern before you really to design your table structure. So what I mean about that, because in the NoSQL database, you will distribute your data to different nodes. So how you design I don't think I can explain this very simply, but they require you have a partition key. Partition key is something to tell your database which node. We have a lot of nodes. Tell which node you go to look for this data. And this sort key is a group server of the same partition key together. So you have to design it very carefully. If you don't know, like I have a new app, like the cloud app we have, so I don't really know in the future what feature I want to add in. So I don't know how I want to query my data. You can now really use it. I mean, you can, but the performance should be very, very bad. If you don't have this access pattern as satisfied by your table structure, you have to scan all of the table to retrieve that problem. And you can do nothing about that, but to make a new table and copy everything between the two tables. There's a lot of company pay price for that.
So partition key and the other one is sort key, you said?
Sort key.
Sort key. And so if this is like the JSON.
Let me tell you this part.
Okay.
You see this? This is very naively. I just get NoSQL database. I say, oh, every table should like this. You can say, oh, this is user table, right? You have ID, name, surname, email. Yeah, that's simple. And in reality, you will design some table like this. Couldn't know what it's for. Couldn't read it. Nobody can read it.
It's address.
Nobody can read it. What is for? And what information represent? Nobody can read it.
Spark ebook.
ebook, and
What
a
about
book,
this?
and a book,
A book.
Ebook.
a book.
A book. And what about this?
Well, this is like
Girls
say
one.
user 1 and then user 2, but not really, because again, you're doing redundancy, right?
Doing redundancy, just want to satisfy your fire department. This is, nobody can really read it. Yeah. So that's why I mean is the query is not flexible. You design this exactly for your workload, for your application. So if you change your requirement, you will die with this. So the thing I recommend, just at the beginning, you want to make a new app, use a relational database at the beginning. And relational database actually can scale very wide until you 10 million users. That should be fun. Because this technology is pretty old, pretty mature. You can find any solution online, just Google it. You will get very, very nicely, how to optimize your performance, something like that. So, at that moment, you really cannot scale that. You want to go to the NoSQL. You can put just one table. This table is really hard to monitor it to the SQL, to the NoSQL database. At that moment, you should be know what is export and you need, so you can design something. And other restriction is like an item size, like when each row no more than 400 kilobyte, and the query size no more than 1 megabyte. If you more than that, you have to do the pagination. It's a very requirement because they want to satisfy the performance requirement like this. How they got this is has some requirement there. If you go over that, definitely you cannot see that performance.
So would you, are these hashed for performance reasons or security?
It's for the performance. Yeah. Especially the distributed database using different nodes.
Yeah.
They have to transfer via the network. Even too big doesn't work. In the one machine, then no problem.
But it's nice when you only have one hash in your hash bucket. But what if you have like, I don't know, let's say 50 hashes in your hash bucket, you only have 1 megabyte.
You do the pagination. They will give your start number. But when you query this like this, you have trillions row. They will retrieve 1 megabyte data for you and give your start number. And the next query, you make another query, go after it, and make another query to go after it. Yeah, do something like that. But you have to make more queries.
So they begin to decorate. So
This is actually, you require 1 megabyte data. This is a lot.
Yeah.
You transfer. You can think about it. You have to retrieve this data and also transfer it to your front end user. Right? So you transfer one megabyte. This is require time. So whether the user, let's say you totally data like 100 megabyte, you probably should not put all the data at one time. This is not best practice. So they also enforce that. You can, I mean, but it is not very good user experience.
So when you say pagination, is this the one that I know, that next page? Okay.
You do the first query, you will give you a number
Yeah.
to where you stop, and you do the next one, start with the number, and then you give other numbers. You do it again and again. Retrieve all of the data. And the last one is one we should use it. The one big thing is OLTP app. What is the OLTP? So the app, usually we have two different kinds of app. One is called OLTP, online transaction process app. That's something most of app actually is going to this kind. Like we have a bank, we have a transaction. We have to do this for add money and put it in my account. Give me return and give me receipt. That you have transaction one by one step So that one, which means you know your access pattern, which one you have this problem will define very clearly. I know I will retrieve this data, insert this data, return this data. So this is a good user case for this NoSQL data. How you know how you want to retrieve your data. And other one is called OLAP, OLAP. So it's online analytic process. So which means I have this data there. I want to run some analytic query on my database. But in that point, you don't really know what kind of query you want to run. I want to analyze today. I want to combine this to maybe other day. I want to retrieve based on this two attributes. So this is not the ideal to use NoSQL data for data science. Hard to say. Another this actually connect to each other, right? Other use cases, big data, because we say the relational database, they have a limitation, especially, the CPU and memory and more, especially for the hard disk space. You really have a lot of data. You cannot put it in the one disk. It's hard. But so the distributed database, they don't have that problem. I can't that's wrong. So another one is the low latency requirement. If we really need very, very low latency to retrieve the data, NoSQL database, will design NoSQL database to your front. You can really get fast, maybe just less than 10 milliseconds. You can do that. Even though you have trillions of rows, you can retrieve data like this. It's low latency. Yeah. Okay, I think that's all. Any questions? Thank you.
Thank you.